Today's lesson will cover exponential decay. This lesson will be broken down into 5 sections. Questions 1 to 3, 4 to 7, 8 to 9, questions 10 to 14, and then we'll wrap up the lesson with questions 15 through 17. Let's go ahead and take a look at the first section. It says, radon, a naturally occurring radioactive gas, was identified as a health hazard in some homes in the mid-1980s. Since radon is colorless and odorless, it is important to be aware of the concentration of the gas. Radon has a half-life of approximately 4 days. Tony's grandparents' house was discovered to have a radon concentration of 400 pci/L. Renee, a chemist, isolated and eliminated the source of the gas. She then wanted to know the quantity of radon in the house in the days following so that she could determine when the house would be safe. It says, 1. Make sense of problems. What is the amount of radon in the house 4 days after the source was eliminated? And explain your reasoning. Now, half-life states all radioactive elements have a half-life. A half-life is the amount of time in which a radioactive element decays to half of its original quantity. So half of its original. And it says the half-life is every 4 days. So that means that if they start out with 400 pci/L, and 4 days later they go back in and they try to identify how much concentration there is, this number would decrease by half. So that means we're basically either multiplying by 1/2 or dividing by 2. So this would be 200 pci/L. Every 4 days, we multiply by 1/2. Compute the difference in the amount of radon from day 0 to day 4. On day 0, there was 400. On day 4, there was 200. Remember that this means subtract. So the difference would be 200 pci/L. Determine the ratio of the amount of radon on day 4 to day 0. Ratio, division, fraction. Create you a fraction. So day 4 was 200. Day 0 was 400. And if we simplify this, 200 divided by 400, math frac, it gives me 1/2. On to the questions to go along with this section.